Hi Chloe. So I think the best way to feedback to you maybe would be to make a video. I'm going to actually go through each question. You've done okay in them all as far as I can see. I have something to help you in them all as well though. And I can help you all right with two, 3 and 4. Question 1, mathematical modelling isn't really something I'm familiar with, but you have a definition for maths as fun, and I can only presume that's correct. And the diagram I think is okay. Now, state whether each are physical or mathematical. Financial forecast, I think you've as mathematical. Model plane, you said was physical. A new car design, you said was physical. Now, part 4, you said was physical. I'm fairly sure an equation used to calculate the area of the kitchen floor will be mathematical, okay? The reason I would say that, equation, calculate, area, okay, those words are all quite mathematical, as opposed to the kitchen floor, which is physical. It's an equation. So I can help you out with 1D for sure. So Mary, you had 24 oranges for 1.6 litres of orange juice. So that's a ratio question. So the first thing I've done, or I'm about to do, is I have my calculator, and I'm going to do 24 divided by 1.6, and that gives me 15. So that means the ratio is 15 to 1. That means 15 oranges for every 1 litre of orange juice, okay? So we want 40, is this, where are we going again? Sorry, 4 litres of orange juice. So we're going to multiply 1 litre by 4, and that means we have to multiply 15 by 4. So that tells us 60. So model this problem. I think you can translate what I've given you here into your solution or your model, and what I have there might even do. How many oranges should Mary buy? She should buy 60 oranges for her 4 litres. Okay, I hope that bit helps you, Chloe. I'm going to do similar for each one. Okay, for question 2, I've copied some of your stuff. So continuous and discrete, I'm happy enough. That's good. You wrote the numbers in order, and you highlighted the 2 middle numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You add them together, you divide by 2, you got the median correctly. So I'm not happy with the first quartile. You don't need the second quartile, which is actually the same as the median, but that's fine, there's nothing wrong with that. And I am happy with the third quartile. So therefore the only thing I won't be happy with is 25, the first quartile here, which obviously throw off this answer. So I don't know how you got the lower quartile, but the way I look at it, there are 12 pieces of data, and so 12 plus 1 divided by 2 is divided by 4. Okay, so I'm going to go to my calculator here. 13 divided by 4 equals 3.25, and then I'm going to multiply that by 3 to get the upper quartile, which is 3/4 of the way through the data, and that's 9.75. Okay, so let me show you what I'm doing here, or what I'm thinking. You might remember this. So 3.25 means 1, 2, 3. It's between the third and fourth piece of data. So what you did is fine, but it should be between 26 and 28. Okay, divided by 2, so that's 27. Okay, for the lower quartile. And just let me verify that with what you did earlier. So between the 9th and 10th, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's between 44 and 50, which you added them together, you divided by 2, you got 47. So that's why I agree with that. So I think you should have 27 here, and therefore you should have 27 here, and that'll change your answer. Okay, not a huge deal. So median interquartile range. Okay, that's all that one done well. Right, Chloe, you did the mid-interval values here correctly. So 10 and 18 was 28, 14, 23, 32, 41, 50, and 59. Okay, now remember that the number of patients is the frequency and the age is x. So the mean is the sum of f times x divided by the sum of the frequency. Okay, so this is what you need to do. I'll let you do the calculations, but I'll write them out for you. So the frequency is 11, so that's 14 times 11 plus 23 times 14 plus 32 times 9 plus 41 times 7 plus 50 times 5 plus 59 times 3. And we divide that by the sum of the frequency. So the frequency is 11 plus 14 plus 9 plus 7 plus 5 plus 3. You can put all that into your calculator, and what you get out will be the mean. So remember, it asks you for the mean age. Okay, so on the top, basically you're getting the total age of adding up everybody's age of all those people, which is quite a lot, or quite a high age, and then all the people is on the bottom, and that'll get you the average age of the people, wherever they are in the hospital or something. Okay, Chloe, question 3. 2 dice are thrown. What is probably the total of the 2 dice? Will be 4 or lower. So I don't know, do you remember this kind of a table? So the 2 dice are represented in the black text. So the total, I presume, is what you get when you add them. It should really say the sum. So it will be 4 or lower. So I'm just going to highlight the ones. 1, 2, 3, 4, 5, 6. All of the rest of those answers or totals are more than 4. So the answer for part A will be 4 out of, there are 6 times 6, 4 out of 36, which is 1 out of 9. Okay, so that's part A. Part B, I think you had right. Red is 8 out of 40. Not green is 12 and 8, it's 20 out of 40. You could probably simplify these in your calculator. So that's not green. And the last one then is green or red. So green is 20, red is 8. So that's 20 plus 8 is 28 out of 40. Okay, and you should probably write the probability of green or red equals. Okay. Okay, I'm going to make a new little bit for part C and part D because they're going to take a bit of space. Okay, Chloe, you had one small mistake here, I think. So just consider that, right, the code will have 5 digits. So I'll just set it up like that for the first one. I won't bother for the second and third. So the digits 0 to 9, but we're not counting 6. So to count these, 0, 1, 2, 3, 4, 5, 7, 8, 9. That's 9 digits. So he can put 9 digits here, and he's allowed to repeat. So it's 9 by 9 by 9 by 9 by 9. Okay, and that'll be how many different combinations he could make there. So the next question, repetition of digits not allowed. Okay, so he can choose from 9 for the first one, but now he's used 1, so he can't use that one again. So he only have 8 left. Now he's used 2 of them, so and so on. So there's 1 less each time. Okay, for part 3, repetition is allowed, but he wants the number to be even. If it's an even number, the last digit has to be 2, 4, 6 or 8. Now it can't be 6 because he doesn't like it. So it's 2, 4 or 8. 2, 4 or 8. That means he has 3 digits to choose from. And then it's 9 by 9 by 9 by 9 by 3. Okay, for the last digit must be 2, 4 or 6. Okay, part D, Chloe. I just want you to have a look at yours again. I don't think you copied the table correctly. Okay, so the relative frequency of sixes. So I have my calculator here again. So he got 3 10s after 10 rolls. So that's 3 out of 10, which is 0.3. After 20 rolls, he had it 5 times, he got 6. So it's 5 divided by 20. After 30 rolls, so that's 6 divided by 30. After 40 rolls is 9 divided by 40. 0.225 is 22.5%, which we're not talking about percentages, sorry. So 0.225 and then 10 divided by 50. Okay, so 0.2. Okay, filling in the relative frequency as a decimal, yeah, as a decimal, okay, of rolling a 6. You drew a trend graph, Chloe. You drew the trend graph correctly, but you did it for the wrong information. So I won't do that for you. Just have a look at what I did there and you'll be able to fix your trend graph. Okay, after 40 rolls, Edith felt that the dice was biased against sixes, given what she knew at the time. So 40 rolls, she got number 6. I'm going to write it 9 times, which was a decimal of 0.225. Now I want you to consider the chances of getting a 6 are 1 in 6. So we'll go to our calculator again and we go 1 divided by 6 and we get 0.166 recurring. Okay, so she actually got the number 6 more than the actual probability of getting a 6. So explain, was she correct to think that? No, she wasn't. Okay, and she got the other way around. In fact, if anything, the dice was, it probably wasn't. Explain your answer, the relative frequency and the actual. Anyway, this is the important number and this is the important number. She got it close to be fair. It's not a million miles away from the expected probability. Okay, I wouldn't even say it's biased in favor of, but it definitely wasn't biased against, judging by the information. Hope that helps. Right, Chloe, we're on to question 4. So the inverse is a function is something I'm not really that familiar with. I've had a look on Maths is Fun. Okay, so I'm actually going to do the example that's given already. Okay, and you can adapt it for your own. So this one says f of x equals 2x plus 3. So it's not too different to your own. Don't worry about what order they're written in, just be careful with the signs. So you see the 2x plus 3 means you take x, you multiply it by 2, and then you add 3 to your answer. And I wanted to do that backwards. So instead of multiplying by 2, we're going to divide by 2, and then we're going to take away 3. Okay, so it'll be y divide by y minus 3 divided by 2, and it's written as f to the power of minus 1, which is the word inverse of y. Okay, so I think you had a similar idea. Again, I'm not all that familiar with it, but the important thing is just to recognize that it goes the opposite direction. Okay, Chloe, so for part 1, your line is 2x plus y equals 3. Now I'm not sure exactly how you might have been taught to do this, but I'll show you what I know about it, the way I approach it. So if we write as y equals minus 2x plus 3, okay, I took away minus 2x on both sides. That's in the form y equals mx plus c. M is the slope, So m equals minus 2. Okay, that's part 1. Part 2, the parallel will have the same slope, so m equals minus 2, and it tells us the equation 1 minus 1, and that'll be x1 y1. So the formula, you don't need to know this off, I don't think. Y minus y1 equals m times x minus x1, and we sub it in. So y minus negative 1 equals minus 2 times x minus 1. Minus the negative is positive, plus minus 2x. Minus 2 by minus 1 is plus 2. And I'm going to take away 1 on both sides, which is going to give me y equals minus 2x plus 1. Okay, so that line is parallel to the other one. I think I might fit in part 3 here. Find the equation of the line which is perpendicular. So a perpendicular slope. So the slope we have is m equals minus 2, which is the same as minus 2 over 1. A perpendicular slope, we'll turn it upside down, that's 1 over 2, and we'll change the sign. So this slope is negative, so this slope will be positive. So that slope now, this one, is perpendicular. So you can go back, you can use this formula, this slope, and the point 2, 1. Okay, I'll let you do that one. And I think your sketches were fine of the lines, okay? If you want my help with those, just send me another email, and I'll give you a hand with those. I'll actually check your ones again. Right, Chloe, I'm looking at question 4, part C. So I think it was 2x squared plus 2x, and it was minus 3. Okay, so your graph, I'm sure, was off a little bit, because I'll pull this over and drag this up. So it's 2x squared, which means it's a U shape, you had that. And the minus 3 here standing on its own means that's where it cuts to y-axis. So you can see the y-axis, and you can see minus 3 there. I'll send you the link for this. Okay, Chloe, I've copy and pasted the diagram. Now, I just look here in the domain minus 2 to 3. So like it should start here, but it should finish, you know, well up along here. I don't think you'll be docked too many marks for it, because I think it's way up. But anyway, what I've given you there is fairly, is nearly enough. It's quadratic, you said that, and you got it right, well done, because it's a U shape. So part 3 says find the graph where f of x is less than 0. Okay, less than 0 means underneath the x-axis. So from here all around to here. Okay, I think it might be enough to mark it, but if we were going to write something, it's minus, I suppose, 1.8 less than or equal to x less than or equal to maybe 0.8. Now that's an estimate of it's an estimate of what we're looking at there. Okay, hope that helps. Okay, Chloe, I'm going to go over and back here between the question and the solution. So part A says to write the objective function for this problem. Okay, now this linear programming is brand new to me, and my fiance and I spent a lot of time doing this question, but it was satisfying enough. I think we worked it out. So we think that the answer to this is 50x plus 40y. Okay, that means x was pants, so the number of pants sold by 50, the price, plus the number of jackets sold by 40, the price, and that'll give you the total amount of money, or the total profit. That was, sorry, part A, not part 1. Part B asked us to write down the constraints for this problem as a system of 4 inequalities. So I think the constraints were the 1 meter squared by the number of pants plus the 1.5. This represents the cotton, I think, 1.5 meter squared of cotton by the number of jackets, and that has to be less than or equal to 750 meters squared, which is the amount of cotton. This one is for the polyester, so 2 meters squared for the pants, plus 1 meter squared for the polyester. That has to be less than or equal to 1,000 meters squared, because that's how much polyester he has. Now, we also calculated that the very highest number of pants he can make is 500, because you'll see where that if he makes 500 pants, sorry, now I'm just making my way through this question again. For every pair of pants he needs 1 meter squared of cotton and 2 of polyester. So if he needs 2 meters squared of polyester and he has 1,000 meters of polyester, that means the most pants he can make is 500. And actually the same applies for the jacket. 750 meters of cotton and he needs 1.5 for every jacket. 750 divided by 1.5 will bring you back to the 500 for Y as well. So Y is less than or equal to 500 as well. Okay, question C asks you the coordinates of the feasible region. Okay, so we took this graph. I'm going to take the highlighter for this, and that's as close to purple as I have. So this one represented the pants, the purple one, and the red one went red-ish, I suppose pink is as close as I can do there. Okay, the pink one represented, sorry, not the pants, but the cotton. The first one was the cotton and the second one was the polyester. So we also need to make a line for x less than or equal to 500. So that's this vertical line here. Okay, x is 500 all along there, and it really doesn't influence it too much. And then y less than or equal to 500 is this line here. Okay, so the feasible area I'm going to do in light gray is from here to here to here to here to here. I'm going to highlight it like that. Okay, and I'm going to mark in green this point, this point, this point that's already marked in blue, and this point. So let's just go back to the question. The coordinates of the 4 points that are at the 4 corners, i.e. the vertices, the feasible region. Okay, so the feasible region will be, hard to see, it said to include 0, 0. So 500, 0, 0, 500. And I think the most important one is 375, 250. Okay, so D asks us to draw the graph. Okay, so the graph is done. So I think X represented, just let me double check. Let X represent, yeah, X represented the number of pants. Okay, remember this axis here is the x-axis, and this axis here is the y-axis, which represents the number of jackets. Okay, So he could make up to 500 jackets, that's along the y-axis. He could make up to 500 pants, that's along the x-axis. But there's an optimum number that will help him make the most money, okay? So I'm going to actually erase the D there because I need to make a little bit more room. So E. So let's go back to the question for part E. The maximum number of pants, what number of pants and what number of jackets in order to make the maximum profit. The maximum profit. So he should make 375 pants and 250 jackets. Okay, and part F, the pants make a profit of 50 each. The jackets make 250 jackets make a profit of 40 each. Okay, and the total there, I wonder was it euros, that will make 28,750 euros profit for this tailor. Okay, I hope that makes sense. I probably haven't explained it that well because it's my first time experiencing something like that, but it probably makes more sense to you because you've been studying this, hopefully.